Hello, welcome back to Cinderella Math. Today I'm going to be doing a couple problems that one of my tutoring students has sent over. This is an Algebra 2 level. I also think it's pretty difficult Algebra 2, so pre-calc probably would apply for you too. If you're studying for SATs, this is probably good for that as well. This is like a little bit of a hodgepodge. It's factoring, but it's also rational expressions. It's also graphing irrational. I have about 20 minutes, 25 minutes before I have a student, so I'm going to be going fast. Pause me if you need to. And again, this is just kind of a random paper that one of my Algebra 2 students has sent over, and I'm looking there at number 7. We have a rational expression of 3 over x minus 5. Let's go ahead and put that over 1 to make it look like a fraction. And on the bottom, we have 4 minus 9 over x squared. Let's go ahead and put the 4 over 1. Alrighty. So you're going to work the top and the bottom separately. So let's just look at the top. So 3 over x minus 5 over 1. We need a common denominator. So let's times by x on your right-hand side. That would give us 3 over x minus 5x over x. Yay, they have a common denominator. And now we can go ahead and make that into a big fraction since they have the same denominator. That would be 3 minus 5x all over x. And that's the best we can do for the top. Okay, let's now look at the bottom. So that's going to be 4 minus 9 over x squared. Let's get a common denominator. So on the left, we're going to times by x squared. And that will give us 4x squared over x squared. Minus 9 over x squared. Yay, common denominator. We can make that into a big fraction. 4x squared minus 9 over x squared. And that's going to be the bottom. Okay, so let's put this back into our big fraction form here. So the clean answer for the top was 3 minus 5x all over x. Divide, the answer for the bottom was 4x squared minus 9 all over x squared. All right, we don't divide fractions. We keep, we change, we flip, but before we flip this one, that top, the numerator of the bottom, is a difference of squares. So we can factor that one. So I'm going to keep the top, and I'm going to factor that numerator of the bottom. Remember, difference of squares, you take the square root here. So that would be 2x for me, 2x for you. Take the square root here, so that's 3 for me, 3 for you, 1 plus, 1 minus. And now let's keep, change, flip. Nothing else will factor. Okay, so we're going to keep the top exactly how you see it. So 3 minus 5x over x, change the division to a times, flip the bottom. So x squared will be on top. And that factorization of 2x plus 3, 2x minus 3 will be on bottom. You can try to cancel at this point. Crossways, these can cancel, or a little bit can cancel, right? Because this x squared is really x times x. So crossways, this 1x will knock this x. Okay, what's left on the top? We have x and 3 minus 5x. On the bottom, we just have those factors, 2x plus 3, 2x minus 3. That's the best you can do. That is answer. Nothing else will factor, nothing else will cancel. That's it. I worked this last night as well, just on a piece of paper, and I believe I got the same answer, but I'm checking that right now, but pretty sure. Yeah. Okay. I know I'm going fast. Again, pause me, rewind if you need to see that again. That was number 7. And that would have been simplifying a rational expression. Number 8, I'm pretty sure we're just supposed to factor. So, looking at that thing, that is a 4th degree. So I'm going to just write it out here. 4x to the 4th minus 31x squared plus 21x plus 18. My first thought is to maybe factor by grouping since it has 4 terms. So usually we put the first 2 in a group and the back 2 in a group. Then you do the greatest common factor out of each group. So it would be x squared, 4x squared minus 31 plus 3, 7x plus 6. But the trick with grouping is these two, like the leftovers, have to match, and they don't. So we tried grouping, but that failed. All right, and now, since that failed, I'm kind of stuck, and we need to use the rational root theorem or the rational zero theorem. And this is where I think this one's more of a pre-calc problem than an Algebra 2 problem, but that's my opinion. So we need to use the rational root, you could also call it the rational zero theorem. This will say the possibilities for this function, for its roots or its zeros or its solutions. So the possibilities, you take the back number, so 18, and list out its factors. Well, what goes into 18? 1 and 18, 2 and 9, 3 and 6, okay? I go least to greatest. You don't have to. I just like the neatness of that. And then you take the front number, so 4, and list out its factors. Well, what goes into 4? 1 times 4, and 2 times 2, but you don't need to double list. And now you divide the lists. So 1 divide 1 is 1. 2 divide 1 is 2. 3 divide 1, 6 divide 1, 9 divide 1, 18 divide 1, and now you got to divide, go this way now. 1 divide 1, we already did. 1 divide 2, so that's a half. 1 divide 4, that's a fourth. 2 divide 2, well that's 1, that's already on the list, and 2 divide 4 is 2/4, which is a half. It's already on the list. 3 divide 2, well that would be 3 halves, and 3 divide 4 would be 3/4. 6 divide 2, that's 3, that's already there. 6 over 4 would reduce to 3 halves, that's already there. 9 divide 2, well that's 9 halves. 9 divide 4, that's 9/4. 18 divide 2 is 9, that's already there. 18 over 4 would reduce to 9 halves, that's already there. And then give every single one of these a plus minus. That is the rational root or rational zero theorem. And these are not guaranteed to be answers, but these are possible answers. So if it just was list the possible roots, there it is. And now you are just going to take your best guess with synthetic division to see which one of these works. Now, for the sake of time, I'm not going to just sit around and guess. I'm going to use one that I know that works, and that is 2. So positive 2, I'm going to put in the box, and now do synthetic with the original polynomial, but watch out. See how it goes from 4 to 2? This had 0x cubed. We do need to put that in. So that would be 4, then 0. Watch out. If you don't do the 0, it will be wrong. Negative 31, 21, 18. And again, I know this one works. I just didn't want to waste time guessing. But it does take, with that many possibilities, it might have taken me a couple guesses to get here. I just kind of skipped that part. Remember the algorithm for synthetic? We drop down, multiply by the box, add, multiply, add, multiply, add, multiply, add. This right here, this means it works. If you don't get a 0 at the back as your remainder, then erase and try again. Pick another possibility. So x equals 2 is an answer, and if they want the factor, let's just minus 2 minus 2. So our factor is x minus 2. Okay, this remaining garbage right here is our new problem. So this is our remainder, this is naked, give him an x squared, give him an x cubed. It makes sense that we're at a cube now because the original was a 4th power. So you should always step down 1. So this is our new problem. So we still need to factor this. So we have 4x cubed plus 8x squared minus 15x minus 9. The 0 doesn't matter because who cares about a 0? Okay, I'm going to try grouping because again, it's 4 items. Well, we could pull 4x squared. That would leave x plus 2. And we can pull negative 3. That will leave 5x plus 3. Ugh, these don't match. Grouping has failed again. We tried, but no go. All right. So let's go synthetic with this, with the new problem. And again, pick from your list of possibilities. Again, this part may take a minute. I'm going to not, guess with you. I'm going to use something that works, but take a minute, could be a couple minutes to find something that works. I'm just going to tell you that -3 works. So I'm putting -3 in the box, and I'm using the new problem. So 4, 8, -15, -9. Drop down, multiply, add. Multiply, add, multiply, add. And again, it works. And again, I already worked this problem. I knew it was going to work. You might have to guess around for a little bit. Okay? This is our new problem. So the answer from that one is x equals -3. To get the factor, just add 3. So we have 2 factors now, up there at the top of the paper. All right, new problem. I'm going to be in blue. So this, who cares about the 0? Naked x squared. It makes sense that we're now at a square because we were at a cube. You should always step down 1. So we're now at 4x squared minus 4x minus 3. Well, that's just a quadratic. Let's see if we can factor that. I factor with magic x, you factor however you like. Do the first times the last, middle number. What multiplies here adds here. If you owe me 6, give me 2. So my factors, x owe me 6, x give me 2, but we cheated. Now if you don't do it this way, if you do it the grouping way, that's fine. When this is not a 1, we cheated, and so we multiplied to cheat. We're going to divide to uncheat. And again, if you don't do it this way, it's fine. So that would be x minus 3 halves, x plus a half, and then I zoop and zoop. 2x minus 3, 2x plus 1. And again, if you did it a different method than me, and you still should get that answer. So the final answer for number 8, the factors, are the 2 we just found, so 2x minus 3, 2x plus 1, and then the 2 that I've got at the top of my page, top right, that we found from synthetic. X minus 2, x plus 3. These can be in any order. There's the answer for number 8. Okay, your work could look different because I actually could have picked this one first and this one second. As long as your final answer comes out the same as me, your work could be different. All right, and then number 9 is basically the same question. Now just solve it. Okay, so we're going to take the answers we just got, the factors we just got, and again, the order doesn't really matter here. So the answers we just got were 2x minus 3, 2x plus 1, x minus 2, and x plus 3, and just set them all to 0. So 2x minus 3, 2x plus 1, x minus 2, x plus 3. All right, move this over. That'd be 2x is 3, divide 2, leave it as a fraction. Move this over, divide 2, leave it as a fraction, add 2, minus 3. There's your answer for number 9. Those are the solutions. Usually we like to put them in a squiggly bracket, least to greatest. So that would be -3, -half, 3 halves, and 2. Some teachers are uptight about that. Some people aren't. You do you. If you have a graphing calculator or you're allowed Desmos, graph this. Don't push the equal 0. And you will see that's where your x-intercepts are. So -3, -half, 3 halves, and 2. So probably something like that. That's what you just found out. The x-intercepts are the solutions, or the zeros, or the roots. That's number 9. And number 10, we have graphing of a rational. Now this is a long process. So just buckle up. Alrighty. There are two things I always do before I factor. I get the y-intercept, which is plug in 0. So this would be 0 cubed minus 4 times 0 squared plus 3 times 0 all over 0. 0 over 0. We cannot divide by 0, so there will be no y-intercept. And the other thing I do before factoring is the horizontal asymptote. That's where you compare the power of the top, so 3, the highest power, so 3. I call this pigs. I will explain this better in another video. I probably already have one, but just go with me. And then the power of the bottom, so 1. And I call that queen. If pigs are bigger than queens, you will have no horizontal asymptote. Again, watch another video to get more detail on that. Okay, those are the only two things I do before factoring. So now, let's look at our problem. X cubed minus 4x squared plus 3x all over x. I see a GCF right here. They all share an x. Let's pull that out. So that would leave x squared minus 4x plus 3 over x. This will cancel. When something cancels, you do get a hole in the graph. To find the hole, you take the guy that cancels, so that's x, and set him equal to 0. So that's just 0. But we also need the y value of the hole. So you plug that back in to the function after the cancellation. So plug 0 into that orange function after the cancel. So it'd be 0 squared minus 4 times 0 plus 3. So that would be 3. That's our y value. So at 0, 3, we have a hole. So we're going to come up, over nothing, up 3, 1, 2, 3, put a hole, an open circle. Okay, and now the rest of the time we are using this function. So our new problem, after the factoring and the canceling, is x squared minus 4x plus 3. And that is just a quadratic. So we're just going to have a parabola. Let's see if this thing factors. I use the magic X, you use whatever you want. So we have 3 and negative 4. Multiply there, add there. What if you owe me 3, owe me 1? Yeah. So this would be x minus 3, x minus 1. And now for our x-intercepts, you set the top, which is all we have, the bottom canceled, set the top to 0. So x minus 3 equals 0, x minus 1 equals 0. So x is 3 and 1. So we have an x-intercept at 3 and 1. So let's graph that. On the x-axis, come over 1, put a dot. Come over 3, put a dot. For your vertical asymptote, it is the bottom set to 0, but the bottom canceled out. We don't have a bottom to set to 0, so we will not have a vertical asymptote. And now, since it's a quadratic, I would love to get the vertex. And remember, you can just look at this form before the factoring. You're going to do negative b over 2a. So this is our b, so it's going to be negative negative 4 over 2, and this is our a. 2 times 1. So that's going to be regular 4 over 2, so that's 2. Now that's the x of our vertex. Now plug 2 back into the function to see the y. So that would be 2 squared minus 4 times 2 plus 3. So that's 4 minus 8 plus 3, so that's negative 1. So our vertex is going to be 2, negative 1. So you don't always have to do that, but since it was a quadratic, I liked to know where the vertex is. So we're going to come over 2, down 1. And now let's sketch this graph. Skip the hole, whee, and it's a parabola. So it's going to go up on both sides because it's a upward facing parabola. There are no asymptotes. And I think we've got all the information other than domain range. All right, so domain is x values. The only x value that can't be is where we have the hole, and that's when x was 0. So x cannot equal 0, or you can write it like this. You can go negative infinity until you get to 0, stop, and you can start back after 0 and go forever. Range, you would think you'd have to throw out the y of the hole, but look, it got covered in. So even though the whole skips over 3, it's fine because it gets covered in. But this thing never goes below this number, and that's why I wanted the vertex. So it never goes below -1. So it's y is bigger or equal, because we do touch, -1. Or in interval notation, you would start at -1, hard bracket, because you do touch, and upward. All right, I know I went fast, but I do hope that was helpful and that you're having a great day. Let me know if you have any questions, and I'll see you soon. Bye-bye.